Chapter 1 review. Now, this is the same review that we did during class. So, if you're absent for class, I'm not going to do both problems. You can look at the answers on the PowerPoint that is also attached to your Google Classroom. I'm going to do the second question for all of them. Okay, so this first one says simplify combine like terms. So, first thing when I'm simplifying, I notice that I have to multiply because there's multiplying going on right here and right here. So I multiply it to distribute that to both terms. So this becomes 12t minus 12r plus 5r. Here I also have to distribute the 25. However, this is a negative 25. If that confuses you, change the actual number 25 because subtraction is always opposite to a plus a negative, if that helps. So when I distribute the negative 25, this becomes a minus 25t, and this becomes a minus 25. Now, if I look at my like terms, here are two t's, here are two r's, so I can combine those. I would have a negative 13t. Here I would have a negative 7r minus 25. And that right there would be my final answer. So on your final, I should see this work with the answer. If you want to get full credit, you have to show your work on your problems. Now, a typical question in chapter 1 would be solving an equation. So again, I'm only going to do the second one. So if I distribute, because I have to first try to get these x's together, I'm going to distribute this. Again, if you prefer to have the subtraction as a negative, go plus a negative, distribute that negative 2.5. So you'll have a 25x minus, because this would be a negative 2.5 times a positive 1, so minus 2.5x. Here's a negative times a negative, so that would give you a positive, and that would give you a positive 7.5 equals 15. I'm going to do two steps here. I'm going to subtract the 7.5 on the other side of the equation. So that would give me 7.5. 15 minus 7.5 is 7.5. And I'm going to combine my like terms. So 25x and negative 2.5x. I can combine those two, leaving me with 22.5x. So now if I want to get this x by itself, I have to move over this multiplication. The opposite of multiplying would be dividing. I do not want your answer written as a decimal within a fraction, so you would actually have to do 7.5 divided by 22.5. It's a repeating decimal. You can turn that into a fraction, and that would be equal to 1/3. So x here is equal to 1/3. Also in chapter 1, we had inequalities. So this question is asking, is it always, sometimes, or never true? We have to solve for x though. So again, first thing I want to do is distribute this x. This becomes a negative 5x minus x minus 3 is less than or equal to 15. I can combine these two like terms, so this becomes a negative 6x. I'm also going to add this 3 over, just because so I don't have to write out too much stuff. Now I can divide by this negative 6 because the opposite of multiplying is dividing. Remember, when you divide by a negative, you switch the sign. Because I'm left with the variable, this is sometimes true. This is only true if x is greater than negative 3. So again, if for some reason I solve this and my x value completely canceled, let's give an example. So if I did an example, one example would be like if I had x minus x plus 3 is greater than or equal to 5, I would be left with 3 is greater or equal to 5. That's true. So that would be always, that's false. 3 is not greater than 5, so that would be never. If I had another example, and if I had x minus x plus 4 is less than or equal to 10, this becomes true. So this is true, 4 is, so this would be always. So those are your three options. If the variable cancels, it's either never or always, depending on what's left over. Otherwise, the variable makes it a sometimes if the variable's still there. Next question to review is to solve the compound inequality. So and statement means it's going to be shaded in between. Remember, when you're shading, it would be shaded in between, kind of like that. Or statement, let's solve this one. So I'm going to solve each one of these separately. So first thing I'm going to do is add over the 6. So 7x be less than negative 35. So x is less than negative 5. That's one of my numbers. Here I have to subtract 14, so 4x, if I subtract 14 would be negative 12, divided by 4, x is greater than negative 3. Okay, so now when I'm graphing this, because you will have to solve and graph, the smaller number, so negative 5 is the smaller number of the two, goes on the left, larger number goes on the right. There's no line for either of these. Both of these will be open circles. This is x is less than, so that means it's pointing to the left. X is greater than negative 3, that's pointing to the right. Or statement should always have the space, and statement should be shaded in between. Next problem to review. I'm actually going to do the A for this one because it's a little bit more difficult than the B. So I'm going to do the A for the video. So I have to solve this absolute value. Remember, absolute values, there can be two answers. First thing I have to do is get my absolute value, that section right there by itself. That would be the same thing as this question would be the same thing as if I had to solve for A first. So my A is my absolute value. I have to subtract over this 3. So this says 4 times my absolute value is equal to 20. Now I have to divide both sides by 4. So my absolute value is equal to 5. Now, since your absolute value is completely by itself, you're going to have two answers. You can have this number equal a positive 5, or this number right here could equal negative 5. Because remember, if that number right there is a negative 5, the absolute value still makes it positive. So I have two different answers. So I have to add over the 1, so 4x would be equal to 6. Here, if I add over the 1, I have 4x is equal to negative 4, because I'm adding that 1. And then divide by 4. So my two answers, x would be equal to either 3/2 or negative 1. So I have two answers when I have absolutes, two answers. And the last question that I'm going to review for chapter 2 is this one. So we have to solve and graph. So same thing though, I'm still going to have two answers. I'm going to solve this one. I should still have two answers. It's either going to be an or an and statement. It kind of depends. So first I need to get the absolute value by itself. I'm going to subtract 2 from both sides. So now I'm going to have negative 26. Now I'm going to divide by negative 2. Dividing by this negative 2 right here flips that sign. So now I have the absolute value. Now that's switching that sign because I'm dividing by the negative 2 of 13. Now, same thing as over here, I set my two equations. However, I set up one of the positive ones, and then I also set up the negative one. So I have to flip the sign. Just like how when we divided by a negative here, we're technically dividing by a negative 1. So I have to flip that sign. Because there's no other adding subtracting in my original problem up here, I am now solved. So now I have to graph it. So remember, your smaller number goes on the left, your larger number goes on the right. No line, so both of these are open circles. This says x is less than 13. This is x is greater than negative 13. So this is an and statement. So you should be shading right in the middle like this. If for some reason you solve this problem and you get something where you have your two arrows pointing in the same direction, you probably forgot to flip your sign when you made your negative. This should not happen. Either they should be shaded in the middle or they should be shooting out. And that's all the review for chapter 1 for the final. Have a great and wonderful day.